Question 8. An object of mass 5 kilograms is projected up the line of greatest slope of a rough plane inclined at an angle of 30 to the horizontal. Given that the deceleration of the object up the plane is 6.3, show the value of mu is 2 root 3 over 21. Okay, sounds a bit complicated. Let's draw a diagram. So, there's my slope. Here's my object on the slope. Okay, it's moving up the slope. Is there a force pulling it up? No, it's projected up. So it's basically being pushed up the slope, okay, or it's being flicked up the slope. Once it's set in motion, there is no forward force. Okay, so what forces do we label? There's our weight force down. We label our normal reaction, which is perpendicular to the slope. And there's obviously a friction force because we're finding friction and it mentions it's rough. And that's going to be opposing the motion. So that's what our force diagram looks like. So when we're doing these questions, we can always resolve perpendicular to the slope. So that's going to give me a link for R to the weight. This angle of 30 here is also an angle of 30 in this gap here. Okay, so I'm going to resolve perpendicular to the slope, and I'm going to imagine twisting this arrow so it points in that dotted direction, and I'm going to crush that angle of 30. So it's going to be 5g cos 30. Okay, 5 times 9.8 times cos 30 gives me 49 root 3 over 2. And because there's surds in this, obviously I need to leave this as a surd. Okay. Another thing I can do is think about in the direction of the slope. Now, it's moving, so when it's moving, you have to apply F equals ma along the slope. And in the direction it's going, so it's going upwards. Okay, so F equals ma, oops, in the direction up the slope like that. So, is there a force pulling it up? No. So I'll start with 0. Minus, are there forces trying to slow it down? Yes, definitely. Friction is trying to slow it down. And its weight is trying to slow it down. So we need to resolve the 5g around to that direction. So we're stretching, so it's going to be 5g sine 30. And that will equal ma. Its m is 5. You don't put the g on that side of the equation. Its acceleration is negative 6.3. It's decelerating. Okay, so that's what your F equals ma equation looks like. So let's just put in a few numbers here. 5 times 9.8 times sine 30 is 49 over 2, which is 24.5. And 5 times negative 6.3 is negative 31.5. And let's just do a little bit of rearranging. Let's take friction over there to make it positive. Let's take this one over here, make that positive. Oops, 31.5 minus 24.5, quicker in my head, 7 for friction. And then all we need to do then is finish by using friction is mu times reaction. That's when you're at your maximum friction, and you're always at your maximum friction when you're moving. Okay, so we're perfectly okay to put in 7 equals 49 root 3 over 2 multiplied by mu. Bring the 2 up. Take the 49 root 3 down. I think we just need to do a little bit of rationalising here. I can also cancel out my 14 and my 49. So divide by 7, divide by 7. So I get 2 over 7 root 3. A little bit of rationalising. I know the calculator will just do it anyway for me. But that's going to give us 2 root 3 and 7 times a whole 3 is 21. So it did look a little bit of a tricky question, but we're still doing the basic things, which is you can always resolve perpendicular. Along the slope, you either resolve if it's stationary, or you apply F equals ma if it's moving. Okay, and the link between them is generally going to be friction equals mu r.